So they teach you in algebra classes that the x-coordinate of the vertex of a parabola is equivalent to negative b over 2a, this expression right here. But then they never really explain why. I mean, my teacher told us that we would learn where it comes from eventually, but she never told us where, or how, or when. But then you learn some calculus, and the relationship between the x-coordinate of the vertex and the negative b over 2a equation becomes ever so clear. Here's what is going on and how we can derive negative b over 2a. So let's suppose we are taking the general formula of a quadratic equation. Y equals ax squared plus bx plus c. So now we're going to differentiate this function with respect to x. So we can do so using the power rule. So now we just drop the 2 out front to get 2a for our first term. Then we subtract 1 from the exponent. Repeat the same step on b. So the x just goes away, and then the derivative constant is always going to be equal to 0. So we are left with 2ax plus b. And that is our derivative expression. So our derivative expression is going to tell us the slope of the tangent line at any given x value we plug in. So in other words, it's going to tell us the instantaneous rate of change for any x value on the original function's graph. Now if we draw this graph of a quadratic function like this, you'll notice at the vertex, if I draw a line that is tangent to it, the slope of this tangent line is equal to 0. And this is true for every single parabola. So now that we understand that the slope at the vertex is always equal to 0, we can find the associated x value where that 0 slope is located, essentially where the vertex is located, by plugging in 0 for our derivative's output, or dy dx. So let's go ahead and do that. So now all we have to do is rearrange some variables. We can move b to the opposite side of the equation. We're left with negative b equals 2ax, and we divide the 2a to the other side, and we get negative b over 2a equals x. And we find our original formula, and this derivative expression is where it all comes from.